In the last class we are solving problems on continuity. So we have solved two types of problems, in which in first case we have examined the continuity of the function. In the second type we have discuss the continuity or find all the points of the discontinuity. I think you have understood those problems. I just have a fast recap of the definition of continuity of the function. A function y is equal to f of x is said to be continuous at x is equal to a if limit as extends to a, f of x is equal to f of a. That means limit as extends to a minus f of x is equal to limit as extends to a plus f of x is equal to f of a. Then second, I have told you about the discontinuity. A function y is equal to f of x is said to be discontinuous if left hand limit is not equal to right hand limit. That is, limit as extends to a minus f of x is not equal to limit as extends to a plus f of x. That is, limit of a function does not exist. Second one, limit of the function exists. That is, limit as extends to a f of x exists and it is not equal to f of a. That is the second condition for discontinuity. I have already told you that a function is said to be continuous means graphically there will be no break in the graph of the function. If a function f of x is said to be discontinuous, then there will be a break in the graph of the function at that particular point. I think you have understood all these basic concepts. We will continue with the problems. It is given find all the points of discontinuity. Please look at the problem carefully. It is given find all the points of discontinuity. Modulus x divided by x. If x is not equal to 0 and 0 if x is equal to 0. You know, x not equal to 0 implies x greater than 0 or x less than 0. You know, we will take when x is greater than 0. See here, when x is greater than 0, you know the definition of modulus function. A modulus x should be taken as x. X by x it is equal to 1. When x is less than 0, f of x will be minus x by x, that's equal to minus 1. So, when x greater than 0, it is 1, a constant function. When x less than 0, f of x is minus 1. 1 and minus 1, you know, both are constant functions. We have proved that f of x is equal to a constant function is always continuous. I conclude that f is continuous. I think you have understood. For x greater than 0, it is continuous. For x less than 0, it is continuous. Now we need to test at x is equal to 0. Now, see here, let us take limit as extends to 0 minus f of x. What is limit as extends to 0 minus f of x? Less than 0. Less than 0 means we will take modulus x as minus x by x, we will be getting minus 1. Limit as extends to 0 plus f of x is equal to limit as extends to 0 plus f of x. For 0 plus greater than 0, modulus x is taken as plus x. X cancels, you will be getting 1. See that left hand limit is minus 1. Limit as extends to 0 minus f of x is not equal to limit as extends to 0 plus f of x. They are not equal. Since they are not equal, we just conclude that f is not continuous. F is not continuous at x is equal to 0. So, discontinuity of first kind. So, for x less than 0, it is minus 1, constant function, continuous. For x greater than 0, f of x is 1, it is constant function, continuous. But at x is equal to 0, left hand limit will be minus 1, right hand limit will be plus 1. Hence, we conclude that f is not continuous at x is equal to 0. Then, which is the point of discontinuity? So, point of discontinuity is x is equal to 0. X is equal to 0 is said to be the point of discontinuity. Please understand the problem carefully. Modulus x means plus or minus x. Modulus x is taken as plus x when x is greater than 0 and it is taken as minus x when x is less than 0. I think you have understood this problem. Very simple. And we will move on to the next question now. f of x is given as x divided by modulus x. If x is less than 0, it's minus 1 if x is greater than or equal to 0. You need to find all the points of discontinuity. Remember, we are solving problems on finding the points of discontinuity, all the points of discontinuity. Now, let us take when x is less than 0. Let us take first x is less than 0. What happens when x is less than 0? F of x will be x divided by minus x, I take, which is minus 1. So, see, minus 1 is a constant function. It is said to be, minus 1 is a constant function, hence it is said to be f is continuous. That's what the conclusion we draw from this. When x is greater than 0, see, when x is greater than 0, what is f of x? When x is greater than 0, f of x is minus 1. So, what happens now? It is minus 1 means it is constant function, f is continuous. See, for less than 0, it is minus 1. For greater than 0, it is minus 1. At x is equal to 0, it is minus 1. So, obviously, left hand limit is equal to right hand limit is equal to f of 0. I conclude that f is continuous at x is equal to 0 also. So, what is your conclusion? It is continuous at x less than 0, it is continuous at x greater than 0, and even at x is equal to 0, it is continuous. So, what is your conclusion from that? We conclude that f is continuous at all points. There is no point of discontinuity. If you are confused, you can write this at x is equal to 0. If you write limit as x tends to 0 minus f of x, left hand limit as x tends to 0 minus f of x. What is that? X divided by minus x. We will be getting x. It cancels minus 1. Limit as x tends to 0 plus f of x. What is that? Limit as x tends to 0 plus greater than 0. It is minus 1. Now, f of x is equal to minus 1 at x is equal to 0. F of x is equal to minus 1. So, I write limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x is equal to f of 0 is equal to minus 1. So, I conclude f is continuous at x is equal to 0. For x less than 0, it is continuous. For x greater than 0, it is continuous. Even at x is equal to 0, it is continuous. Hence, we conclude that f is continuous at all points. Hence, there is no point of discontinuity. That's what the conclusion is. I move on to the next question. Find all the points of discontinuity. A standard problem. F of x is equal to modulus x plus 3. Write down the problem carefully. If x is less than or equal to minus 3, that's what given. Minus 2x if it is minus 3 less than x less than 3. It is given as 6x plus 2 if x is greater than or equal to 3. Let us write this is, you have to find out all the points of discontinuity. When x is less than minus 3, what happens when x is less than minus 3? F of x is equal to mod x plus 3. Mod x is taken as minus x plus 3. You know why? Since x less than minus 3, I have to take modulus x as minus x. Suppose if x is greater than or equal to minus 3, then you have to take modulus x as plus x. Remember, this is a polynomial. Hence, for all values less than minus 3, it is said to be continuous. I think one point is clear for you. For all x less than minus 3, it is continuous. All values you can take, all negative values you can take, it is said to be continuous. Let us take when x greater than 3. What is that? When x greater than 3, it is 6x plus 2. Now 6x plus 2 is a polynomial, hence it is also continuous. 2 points are clear now. For x greater than 3, for x less than minus 3, it is said to be continuous. Further, I take when minus 3 less than x less than 3. What is that? Minus 3 to 3, it is given as minus 2x. Minus 2x is also polynomial. In all the 3 cases, we have got polynomials. We have already proved that every polynomial function is continuous. So what is my conclusion? F is continuous at all these points. Which are those points? For x less than minus 3, it is continuous. For x greater than 3, it is continuous. For all values between minus 3 to plus 3, it is continuous. Now we need to test at 2 points. Which are those points? At x is equal to 3. And which is the another point? Another point is x is equal to minus 3. Let us take at x is equal to 3. So I take limit as x tends to 3 plus f of x. 3 plus means greater than 3. Which is the function defined for greater than 3? It is 6x plus 2. Substitute the value 6 into 3 plus 2. What is that? 20. 6 3s are 18. 18 plus 2 is 20. So right hand limit is 20. Let us find out the left hand limit. What is the left hand limit? Limit as x tends to 3 minus f of x. 3 minus means less than 3. Identify the function defined for less than 3. For less than 3, it is minus 2x. Minus 2x means minus 2 into 3. It's equal to minus 6. So what happens now? Right hand limit is 20 and left hand limit is minus 6. So what is your conclusion? Limit as x tends to 3 plus f of x is not equal to limit as x tends to 3 minus f of x. So f is not continuous at x is equal to 3. So one point is clear now. F of x is not continuous at x is equal to minus 3. I think you have understood this particular concept now. Now I take at x is equal to minus 3. Let us take at x is equal to minus 3. You need to find both the left hand limit and right hand limit for this. Limit as x tends to minus 3 minus f of x is equal to limit as x tends to minus 3 minus. So we need to take at x less than minus 3. So which is the function which is defined for x less than minus 3? We have to take minus x plus 3. Substitute the value. Minus of minus 3 plus 3, we get plus 6. I think you have understood how to find out this. For x less than minus 3, f of x is minus x plus 3. In which we have to substitute x as minus 3. So 6 we get. Similarly, limit as x tends to minus 3 plus f of x will be limit as x tends to minus 3 plus. Minus 3 plus. Minus 3 plus means identify the function defined for x greater than minus 3. Minus 3 less than x means x should be greater than minus 3, for which the function taken is minus 2x. So minus 2 into minus 3, we get plus 6. Left hand limit is equal to right hand limit. I take at x is equal to 3. See what is f of x is equal to? X is equal to minus 3. Which is the function for x is equal to minus 3? Identify which function to be taken for x is equal to minus 3. So we have to take that as minus x plus 3 only. So we will be taking minus 3, minus of minus 3 plus 3, which is equal to 6. So what is the answer you get? X tends to minus 3 minus left hand limit. Limit as x tends to minus 3 plus f of x, right hand limit, is equal to f of minus 3. So f is continuous at x is equal to minus 3. So what is your conclusion? f is continuous at x is equal to minus 3, but it is not continuous at x is equal to 3 because left hand limit is not equal to right hand limit. Therefore, there is only one point of discontinuity here, which is that one point. That one point of discontinuity is x is equal to 3, in which left hand limit is equal to right hand limit. Please understand the problem carefully. This is modulus x plus 3. When x is less than minus 3, it should be taken as minus x plus 3. That's important. For x less than minus 3, it is continuous. For x greater than 3, it is continuous. For x lying between minus 3 and plus 3, it is said to be continuous. So f is continuous. We need to test at only 2 points. That is at x is equal to 3, it is not continuous. At x is equal to minus 3, it is said to be continuous. Think you have understood this problem? Write down the problem carefully. It's very easy, but only thing is you need to understand the concept. I take up the next one. Is the function defined by f of x is equal to x if x is less than or equal to 1, 5 if x is greater than 1, is continuous at x is equal to 1. That's what the question is. At x is equal to 1. See here, I take limit as x tends to 1 minus f of x. What happens? Limit as x tends to 1 minus f of x. 1 minus is less than 1, which is equal to x. That's equal to 1. Limit as x tends to 1 plus f of x is equal to limit as x tends to 1 plus f of x. What is f of x? 1 plus means greater than 1, it is given as 5. So it is a constant function. Even if we substitute, we get 5 only. Here the left hand limit is 1, right hand limit is 5. What is your conclusion? Limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. Left hand limit is not equal to right hand limit. What is your conclusion? F is not continuous at x is equal to 1. So since left hand limit is not equal to right hand limit. Suppose if they ask the same problem and as is continuous, is f of x is continuous at x is equal to 5. X is equal to 5. See, when they ask you to find out the continuity at x is equal to 5. See, left hand limit means 5 minus. Which is left hand limit now? You have to take 5 only. Because it is x only when x is less than or equal to 1. When value of x is less than 1, then only you can take x. Slightly less than 5 means it is 5 only. For right hand limit, 5 plus, it is 5 only. And when x is equal to 5, it is 5 only. Because f of x is 5 for all values of x greater than 1. Suppose if the same problem is asked for test for continuity at x is equal to 5, we say that left hand limit is 5, right hand limit is 5, and at f of 5 is also 5. So we conclude that it is continuous. I think you have understood this problem. Very simple and easy to understand. Now, next problem. What is given? Is the function defined by f of x is equal to, what is given? X plus 5 for x less than or equal to 1, x minus 5 for x greater than 1 is continuous. We have to check whether it is continuous. They have not given the point, remember, they have not mentioned the point, just they have asked to test for continuity without giving the point. So we write it like this: when x is greater than 1, f of x is x plus 5. So it is a polynomial. I conclude f is continuous. For all values of x greater than 1, it is continuous. Alright, when x is less than 1, which is the function to be taken for x less than 1? So for x greater than 1, it is x minus 5. For x less than 1, we have to take x plus 5. So I write f is continuous. So we are finding out all the points of discontinuity, and for all x greater than 1, it is a polynomial function, continuous. For all values of x less than 1, it is x plus 5, it is said to be continuous. Now let us take at x is equal to 1. When we take at x is equal to 1, limit as x tends to 1 minus f of x is equal to limit as x tends to 1 minus is less than 1, which is the function defined for x less than 1, which is x plus 5. It is 1 plus 5, which is equal to 6. I think you have understood. Less than 1 means x plus 5. I take up right hand limit as x tends to 1 plus f of x. Limit as x tends to 1 plus means greater than 1. Which is the value defined for greater than 1? Greater than 1, it is x minus 5. Substitute the value 1 minus 5, which is equal to minus 5. What is your conclusion now? My conclusion is limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. They are not equal. X tends to 1 minus is not equal to x tends to 1 plus. Left hand limit is not equal to right hand limit. Hence, I conclude f of x is not continuous at x is equal to 1. I think you have understood the method. So, if they generally give means, we need to test for all values of x less than 1, it is polynomial. For all values of x greater than 1, it is polynomial, they are continuous. At x is equal to 1 means we find out the left hand limit, we find out the right hand limit, and we verified that left hand limit is minus plus 6 and right hand limit is minus 4. So they are not equal. So f is not continuous at x is equal to 1. So what is the point of discontinuity? Point of discontinuity is x is equal to 1. That's how you have to conclude. I think you have understood both of these problems. I move on to the next one. Discuss the continuity of the function. Is given f of x is equal to x cube plus x squared minus 1. We need to discuss the continuity of the function. Now, let us take at x is equal to a. So, limit as x tends to a, f of x. Limit as x tends to a, x cube plus x squared minus 1. What happens? A cube plus a squared minus 1. At x is equal to a, what is f of x? X cube plus x squared minus 1. F of a will be a cube plus a squared minus 1. Limit as x tends to a, f of x is equal to f of a. F is continuous at x is equal to a. So I think you have understood, very simple. If you know the definition of continuity of function, you can easily solve this problem. Very easy. Please look at the polynomial given. We can generally state that f of x is equal to x cube plus x squared minus 1 is a polynomial. Every polynomial function is always continuous. You can, looking at the problem itself, you will be in a position to tell whether it is continuous or not. Here it is a polynomial function, hence it is said to be continuous. Next, it is given, discuss the continuity of the function f of x is equal to 1 by x. f of x is equal to 1 by x. Very simple. Let us write the domain of the function. Domain of function. What is the domain of the function? See, if you put x as 0, 1 by 0 is not defined. So, I write the domain of f is R0. That is set of real numbers except 0. Which means to say R0 means real numbers except 0. That is real numbers except 0. I think you have understood why I have written R0. Because when you take x as 0, it will be, the f of x is not at all defined. So the domain is R minus 0. Now, so it is confirmed. Now, let us write limit as x tends to a f of x. Limit as x tends to a f of x. Limit as x tends to a f of x is 1 by x, which is equal to 1 by a. F of x is 1 by x. What is f of a? F of a will be 1 by a. I conclude limit as x tends to a f of x is equal to f of a, that's equal to 1 by a. So I conclude f is continuous at x is equal to b. You know how the graph of the function will be. So last year you have in the first PUC, you have solved problem of this type. The graph will be like this. And the graph will be like this. It is not, graph has no, it will not pass through the origin, because for x is equal to 0, f of x is not defined. So we generally conclude that it is continuous. It is a rational function. In the first PUC functions chapter, we have solved problem. F of x is equal to 1 by x is a rational function. Hence, it is said to be continuous in its domain. In its domain means it is r minus 0, r naught. Now, we move on to another question. Discuss the continuity of the function. You need to solve this along with me. F of x is equal to x plus 2 if x is less than or equal to 1, x minus 2 if x is greater than 1. These are the points. This is the function given. You have to discuss the continuity. You need to discuss the continuity of the function. I write when x is less than 1, f of x is equal to x plus 2. It is a polynomial. It is continuous. I conclude f is continuous because it is a polynomial function. When x is greater than 1, f of x is x minus 2. You know, x minus 2 is also a polynomial. Hence, I conclude f is continuous. So, for x less than 1, it is continuous. For x greater than 1, it is continuous. Let us take limit as, at x is equal to 1. Let us take at x is equal to 1. You know, limit as x tends to 1 minus f of x. 1 minus means left hand limit. Limit as x tends to 1 minus f of x. Which is the function defined for 1 minus less than 1, which is x plus 2. X plus 2. Substitute the values 1 plus 2, which is equal to 3. Let us take the right hand limit. Limit as x tends to 1 plus f of x. 1 plus means right hand limit. Identify the function defined for greater than 1. For greater than 1, the function is x minus 2. So, substitute the value 1 minus 2 minus 1. Here the left hand limit is 3 and right hand limit is minus 1. So, what is your conclusion? Limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. Left hand limit is not equal to right hand limit. Since left hand limit is not equal to right hand limit, I write that f is not continuous at x is equal to 1. See, for all values for x greater than 1, it is continuous. For x less than 1, it is continuous. But for at x is equal to 1, it is not continuous. So what is your conclusion? We conclude that function is discontinuous at x is equal to 1 and the point of discontinuity is x is equal to 1. I think you have understood how to solve this particular problem. These type of problem, many problems we have solved of this type. You need to concentrate and understand these problems. Students, in this class we have solved many problems with respect to continuity and discontinuity. If they ask you to examine and check for continuity, you need to find out the limit at that particular point and find out that f of a. If you are asked to find all the points of discontinuity, suppose if it is given as x is equal to 2, you need to find out for less than 2. Obviously it is a polynomial and continuous. For greater than 2, and then also at x is equal to 2. While finding the continuity at x is equal to 2, you find out the left hand limit and right hand limit. If left hand limit is not equal to right hand limit, then itself you can conclude that f of x is not continuous. It is discontinuity of first kind. If left hand limit is equal to right hand limit, and if it is not equal to f of 2, then we say that it is not continuous, it is discontinuity of second kind. So I think you have understood how to solve the problems of this type. In the next class we are going to solve more problems on continuity. That's all for the day. Thank you.